Hello, everyone. Welcome to the advanced manufacturing recording of our presentation for Chabot. My name is Alan David. I'm one of the outreach specialists here at Chabot. And if you have any questions, please look at the description of this video or the email that's coming from your teachers as well, so you could learn more about these programs. I'm going to have the experts talk about their areas now, so I'm going to hand it off to Adam.
All right, I'm Adam Hathaway. I am the instructor here at Chabot for machine tool technology, specifically specializing in CNC manufacturing and machining. I want to go ahead and throw over to my PowerPoint here.
Let me know if it's not working. Okay, good.
No, we're good. Hopefully, there we go. We can all see that okay, I hope?
Yes.
Yes, great. All right, so I make up, one portion of the advanced manufacturing program here. My colleague, Frank Coe, is the chair of the ESIS program. We also have a manual machining program and a welding program as well. And that's with Liisa and David Toronto. But I'm going to talk a little bit more about specifically CNC machining and a little bit about machining in general. So what is machining? Machining is something that people used to know about, but has kind of fallen by the wayside. And I think a lot of times people kind of think about this guy when they think about machining. Older machines and kind of dangerous work environment, making greasy metal parts. If you actually are familiar with machining at all, what machining really is it's a combination of mostly two tools: a lathe, which is what we're seeing right here, which is a spindle spinning a round part, and that is being machined with a tool that moves in an X and a Z axis, and it makes round parts. So lathes make round things. And then you also have mills. With the mill, the work is what moves and the tool is what spins. So then the table moves with a stationary tool. And so mills make square things. So between the two of these things, actually, there's not a whole lot that you can't make. Some of the things we make: iPhones, microchips, chairs, mice, Teslas, International Space Stations, toilet paper, pencils, headphones, super colliders, nuclear bombs, shoes, Pelotons, aircraft, and most importantly, paper clips. So we make a lot. In fact, I usually use the analogy that we are kind of the shoemaker's elves, right? We do all the work, get zero credit. So the question really is, what can you make? And to that, our program has a lot of things to offer. This is the lab I'm sitting in right now. As you can see, we do a lot of work through computers. We're computer numerical control, CNC machining. So this is part of that computer component. So we have 27 HP workstations running SolidWorks and Mastercam. These are advanced softwares that are industry standard. So if you go off into any basically manufacturing place, any place that has engineering, they're using one or both of these softwares, and you would be too. We have two Stratasys F123 series 3D printers. This guy over here is actually capable of printing flexible polymers as well as carbon fiber ABS, which is basically good for robotic strength parts. We also have a universal laser system, and we also have 6 Haas simulators for lathe and mill. Here's a little more close-up of our printers. These print 12 by 12 by 10, so you can make some pretty large parts in these guys. The other part of our lab is the machining lab over here, which you can see through this window, and we also have another key inspection device over there. The 3D printers, we've done a number of things with. One semester, we just made amplifiers. So here we have a series of different amplifiers, each student designed for obviously their own tablet or phone. And some of these get really good. And this one actually increased the volume by 10 decibels, pretty darn good. Other parts are made, just to whatever students are interested in this case, trailers for RC cars. It's even a competition, so I was glad to help out with that. Other parts for motors, dental tools, whatever it is, make a number of things. We actually had one guy who was the CEO of a company that makes attachments for Velcro, and he made more Velcro stuff. Not surprising for him, but we have a wide range of students that come in here to make their stuff. Laser cutting, here's some of our shameless self-promotion, and something I did for my daughter's grade school. So the projects can really kind of run the gambit of things. This is a quick shot of our CNC lab here. So this is actually one of the older machines. We have several Haas machines in here, lathes and mills, and we also do some 5-axis work, which is sort of becoming more of the industry standard. So here's a quick look at something we did, and I apologize for the resolution here. But what we have here is a 5-axis machine. So we have, 1, 2, 3 axes, X, Y, Z, and then rotary axes. And this is all programmed by students. So this is drilling holes around that flange. And normally this part would take several setups in order to make this with modern machining technology. We here at Chabot make it with one setup where you just clamp it into this thing. And by precise control of this this trunnion, we are able to machine that in one go. And that is the name of the game in machining, is making precise parts and making them faster and faster. And that's part of the education we have here at Chabot. We do a lot of longhand programming, which means you literally type on a computer, and that then gets translated into code that the computers can run. We also run these things called CAMs, which is computer-aided manufacturing software. So this part was made using that. This is a lot of trig. Kind of don't want to do that much trig. We do some, but this we made with software. Here's a few action shots of us at work, and we got our students jobs pretty quickly. In fact, most of these people, these are a bunch of engineering students. But we get a lot of our students out into the work field pretty darn fast, and that's something I'm pretty proud of. We have students working at Tesla, working at the Lawrence Livermore Lab, various job shops all over the place. So if you're into making stuff, this is a great place for you. If you're into making money, this is even better place for you. So this is the percentage of our students who are learning a living wage after the 1 year of exiting our program. That's a very high number. I'll compare it to some other programs later. 70.5% living wage is pretty darn good. And how much are they making? A lot. Again, 1 year after leaving our program, 56,000. That's not bad. So let's compare that to a few other programs. This is just the programs that I can find here, but fire tech, lower living wage, lower annual earnings right off the bat. Accounting, same thing. Now, mind you, there's a little bit of a bias there because, in all honesty, machine tool technology is very hot business right now. In fact, in the next 10 years, machine tool technology and CNC programming, manual machining is projected to grow 20%, not just locally, that's not just Bay Area, that's national. We are seeing a huge boom in the amount of jobs that people are looking for programmers, machinists. We are also seeing a very small number of those jobs going filled. And that translates into a huge opportunity for you, the potential student, to come here at Chabot and really get your hands on some cutting edge technology, no pun intended, make something that's really exciting to you, and at the same time, leave here with a really great certificate or degree and a bright future in a career that really the sky's the limit on. So, I guess I'll pass it back to you, Alan.
Sure. I was wondering, might as well ask questions now so we could separate Frank's part of the presentation. So what actual certificates are available? Are there multiple different ones? And then what degrees can they get after that?
So we have a machine tool AS. That's a 60 credit program. It's 2 years. This is for sort of like a general degree. Covers both manual lathe and mill. It covers the CNC, just the mill, but the CNC mill, and tool and die machining. There's a numerical control associate's degree, another 60 credit 2-year program. Also CNC lathe and mill. And then we get more to the softwares, and that one, SolidWorks and Mastercam. We have 3 certificates. So we have a machinist certificate of achievement. That's 27 credits, about 1-year program. Again, sort of like a general field of study there, manual lathe and mills, CNC mill, and Mastercam. We have a toolmaker certificate of achievement, 31 credits, 1 year. That's more in-depth instruction into specifically tool making. So this is tool and die, mold making, that sort of thing. I get a little bit more into grinding, manual lathe mill, tool making, and CNC mill programming. And then there's an NC certificate of achievement, 36 credits, about a year. We're trying to shave that down a little bit more so that's easier. In-depth instruction for CNC programming, CNC, lathe and mill, SolidWorks, and Mastercam.
Very cool, very cool. Adam, how many students could fit in your lab? Like, is there a limit of how many students you could actually take?
We usually run, we can run up to probably 14 per class. We usually cross-list labs, but it would be great to not have to. And so if we have like 20 some odd students, we'll run them all at once and then separate out our labs that way. Most of what is done in a lot of the programming courses is on the computer. So you're actually kind of plunking away at a keyboard, doing a fair amount of math. It is a challenging program, I'll put it that way. We get into low-level trigonometry, but at the same time, it is also meant to be ramped so that we don't just like drop you right into like geometry or trig. But so we can fit, probably about 20 students per class, depending on how many students we have filling. The software courses fill up a little bit easier, and those we can fit, I believe, 30. And in all honesty, like I've never had to turn anybody away, and I never plan on.
Cool, thank you so much. Jane, did you have any questions you think students might have?
I do not.
Okay.
I do not think so. Sorry, I was just thinking, I do not think so.
If I come up with another one later, I might ask you after Frank's presentation, but thank you so much, Adam.
Thank you.
Thank you, Adam.
All right, so now we're going to transition to.
I learned a lot.
Yeah, I learned a lot too. Like, I need to go
We're
visit.
just right down the hall from each other.
Why don't you walk over there now?
Yeah.
All right, Frank, we'll hand it over to you now.
All right, fantastic. Well, good afternoon. My name is Frank Coe. I'm the lead instructor for the electronics technology program here at Chabot College. And I have prepared a PowerPoint to share with you that will give you a little more insight as to what we do here in electronics technology. So let's go ahead and do this guy here on the screen. Here we go. All right. And welcome to electronics technology is part of a larger division called advanced manufacturing. And included in advanced manufacturing, machine tools, electronics, welding, industrial technology. We share space under this larger umbrella called advanced manufacturing. So let me explore a little bit more about what we're doing here with respect to electronics. And let's go here. All right, as of what time is it? 5:20 now. As of an hour and a half ago, from Indeed.com. These are the job postings that we have seen. Electromechanical technician. The question does come up. You take electronics technology here at Chabot. What can you do with that degree? What can you do with what you learn with the certificates? These are some of the jobs that are in industry as of an hour ago when I pulled this information off of Indeed.com. Tesla's a really big one. We'll talk about this one in a little bit. It points to FANUC. FANUC is a very, very robust industrial robotic device, and we do have a FANUC robot here that we use for training. In addition to that, there's also electrical maintenance technician, lab support. There's a lot of different opportunities in electronics technology. The Bureau of Labor Statistics looks really, really good. All the different areas that we're engaged in. The Occupational Outlook Handbook, again, those numbers look very good. The specific areas that our program supports: electronics technology, computer electronics, industrial electronics, biomedical instrumentation, electromechanical technology, instrumentation, are just some of the things that, some of the category areas of job descriptions. Let's talk about our degree and our certificates. So we have a certificate of achievement. All it takes is 6 courses. And for the eager beavers, because of the way that we've set up our scheduling for the courses, this conceivably could be done in 1 year, although most people do this in about a year and a half to get their certificate of achievement in industrial electronic technology. We also have a certificate of achievement in consumer technology, a different mix of our 6 courses totaling 18 units. And that is another opportunity that, again, conceivably, depending upon the individual, could be done in a year. Here is the list of courses towards the Associate of Science degree in electronics technology. 7 courses, 21 units towards your AS degree, which requires a total of 60 units of your general ed, social sciences, liberal arts, and other courses. But the core courses for electronics are listed here, and it's very achievable within a year and a half, certainly under 2 years. It's very, very achievable. And this gives you a visual look into what our labs look like that students will be working with. Real oscilloscopes, real power supplies, signal generators, real hand, digital multimeters, and then we also have the software computer version of the same on the instrumentation panel here that can be shown on your computer. So we have both real as well as virtual test equipment that we use in our laboratories. And next after this, let's go to here. All right. The benchtop equipment is top notch. This is Tektronix and Fluke are the best among the industry brands that are out there, well respected in the professional realm. This is the equipment that you'll find in the field. This is the equipment that we have in our laboratories for our students. This is particularly interesting, the Occupational Outlook Handbook from the U.S. Bureau of Labor Statistics. I pulled this one out on robotics technician. And a robotics technician, what's interesting here is if we take a look at the comments of an individual, what do you do? What do you do as a robotics technician? He puts down, well, every day my job is to teach a robot. You teach a robot to do certain skills, to do certain tasks. And we do this with something called the Touch Pendant. And the Touch Pendant is this device here. We have these in our laboratory for our students to use to learn to control the FANUC robot. And this is the same controller that is put in their hands if they go to work in any automation industry company. And some people have asked, okay, well, there's different kinds of robots. There's FANUC robots, there's other types of robots. What is the learning curve? The learning curve is very simple. If you can control one type of robot, you can control most of them. because they all work very similarly to each other. Here is a brand new course that we just put together this past year, Liisa 69, and this is our robotics and electronic motor control course. And here, this student's able to earn a FANUC certification upon the successful completion of this course. And they also learn how to work with electronic motors that are used for automation systems, conveyor belts. Think of, for example, you go to the airport, you put your luggage on a thing, and it goes into this little black hole, and somehow miraculously it ends up on your plane and it ends up at your destination where you can pick it up. How does that happen? That happens with a lot of motors, conveyor belts, and a lot of industrial computers. And that's a lot of what it is that we do here at Chabot. Here is an example of our motor controlled word system. And students learn hands-on with high voltage. They learn where to put their hands, where not to put their hands. Everything is monitored and trained, and students are trained very carefully as they're working with three-phase high voltage systems. And let's go here. This one's really fun. Tesla's our neighbor right down the street in Fremont, and they have a couple of very interesting robots that, let's see if I can share this with you just briefly. Get to, okay, right to about here is the starting point. They have a name for their coolest robots. Their most impressive robots. The Wolverine, the claws, and the Iceman, the giant arm that moves these Tesla chassis into place. Very, very, very cool. Well, FANUC is, we use this robot here. It is it's a real FANUC robot, and it is what we use with our students to train them in all the operations of manipulating that arm to get it to do repetitive tasks. Lots and lots of fun. In addition to that, other certifications that are important to our students, A+ certification is for computer hardware, computer software. And that is also part of the training of our electronic systems technology. So A+ is another one. Here is a really, really fun course where we teach automation processes and programmable logic controllers. Let me show you this. So here is where, so there's 3 separate stations for this. This is the, this station simulates bottling and mixture, temperature control. And they concentrate from one vessel to another. Students learn how to control the programming of this, how to read the sensors, how to control to read the temperature so that it's just right before the fluid is transferred. From here, the fluids are transferred to an intermediate station. This is called the bottling station. And this is where containers drop down in a chute and rotate around this table. And as they rotate around, there is a portion where it drops into the table, and then this hose port puts fluid into the container. Then the container rotates around. It caps the container so the fluid is not going to escape. Then it rotates around one more time. And once it's in this position, a separate robotic arm will come down and grab this and transfer it over to the 3rd station. And the 3rd station is palletization. So here is where the finished product is then put into storage in very specific order and pattern, depending upon how our students program things. So this is our upper division course, and this is where students also are engaged in team projects where they take what they learn in the laboratory and apply it to a real world project that the team is going to design and build. We'll talk about projects in just one moment. Let's go to here. Ipc Control Systems. It's great. Here is a great project. First 60 seconds. So what's going to happen here is this train is going to be moving on this track. With one push of a button, this train will be moving on this track. When the train comes to this position here, a sensor will pick it up that it is in position. It will pause the train at that moment. Then the drawbridge will raise and allow the train to go underneath the drawbridge. Once the train has reached the other side, then the drawbridge will be allowed to lower. And then on the return, when the train comes back in this direction, another sensor will pick it up, pause the train, allow the drawbridge to go up. This is a great collaboration of team members' efforts and also applying what it is that they've learned in the electronics lab. The drawbridge goes all the way up, and once it's in the appropriate elevated position, the train moves on. Once it passes the second sensor, then the bridge will come back down. I love it. It's great. And here is another project, fluid transfer. Here's another project where they're talking about HVAC control. And this one's really fun. It's just like just a little bit of it from 220 to 2. Let me go to 220 to 250 mark. Right here, 220. Okay, starting now. Maybe not. Oh, okay, that one didn't work. Sorry. Moving on. Okay, and we also, in the fabrication course, have laser cutting, 3D printing, metal cutting, metal stamping, building projects hands-on. We also, there's an example of the 3D printer actually in progress of making something. It's very interesting when you think about how a 3D printer actually works. It's like a hot glue gun, and it melts plastic into this strand of molten plastic and lays it down in a very specific pattern as guided by the computer program that our students have designed an object to be printed in, and that's what that looks like. That's also part of our program as well. Now, also, this is really, really fun. Students have to learn about electromagnetics. How does a motor really work? Well, this is one aspect where they're actually building a motor. The motor consists of a battery, rubber bands, 2 safety pins, and a coil of wire. And they're able to, with a standard D-cell battery, 1 rubber band, 2 safety pins, and a coil of wire, make the thing work. Good. Look at that. Last semester, we were able to get 3. Yeah, without moving your hand, turn around and wave at us. Hey, good job, my friend. Yeah, they can have fun. We have a lot of fun in our labs. And amazing. Fun. And I love working with high school students. I've got at least 3 years under my belt as a high school instructor, teaching physics and geometry at Fremont Christian High. And we welcome high schoolers into our labs whenever they have. We can schedule field trips. And here's an example of our high schoolers visiting And I gave them a simple electronics lesson and a demonstration, and they built a project to take home to for mom and dad to be able to see. Here they go. Let's go do this one here. And bring this one to the front. All right, let's try this one again. Yay. All right. That's something to be able to take home to mom and dad. Yep. All right. Now that's pre-COVID. We were elbow to elbow, and with COVID, our laboratory capacities have been reduced. But as COVID restrictions are being more relaxed, we're looking forward to our laboratories coming back to capacity. Our laboratory is able to accommodate 24 students, and my supervisor has informed me that yes, with the proper PPE, personal protective equipment, we can again go to achieve capacity. And here's one more that demonstrates our students having fun with high schoolers. It's going, yes, one more in here. Oh, look at this. Wow, it's actually got a motor working. Look at that. Is that cool or what? Made a motor. The smile says it all. All right. And so with that, I want to thank you very much for your time and interest in viewing our presentation. And the bottom line is, are you ready for your career in electronics technology? Thank you.
Thank you, Frank. So now I gotta figure out which one of you I'm gonna join one day. Can't do outreach forever. Actually, you brought it up a little bit, Frank, and I think this question's for both of you. A lot of students that I'm meeting through doing these outreach efforts are wondering about coming back to school, or they're new students. How is it gonna look especially in your areas this summer and fall? Is there an update that you could tell us? Because I think that's what a lot of students are yearning for, is being in person. I know you kind of mentioned it, Frank, but do you know how things are going to come out? And then Adam, if you could tell us also the update in your area.
Yeah, I can certainly address that. Since last summer, we've been conducting our labs in person, in the lab, face to face, with proper social distancing and proper personal protective equipment. And so this summer will be the same. We have 2 courses that are offered in the summer. Entry-level electronics course is offered on Tuesday night, Thursday night. They are both nights, Tuesday and Thursday, for the introductory electronics course. Runs from 6 o'clock till 9 o'clock. And then on Wednesday, we have a fabrication course also open to newcomers. And that runs Wednesday night from 6 o'clock until 9 o'clock in my 1616 lab. So we are planning to have, again, as we've enjoyed since last summer, in person, on campus, elbow to elbow, but with proper PPE. The labs will be in person on campus. Same with the fall.
Great.
Yeah, and kind of similar here for the software. So this is the CAM software, Master CAM, and for SolidWorks. Those are online only. However, they both also have independent projects involved with them. So we would be hosting students on campus for those aspects. So like, you saw the SolidWorks projects where you design something of your own interest. For that, you can come on campus. Same thing though, social distancing, masks. I believe that still seems in the works. I don't want to pontificate on the future there, but it seems like fall semester will probably have PPE. I think we're probably all hoping that we get back to normal past that, but we'll see. For the other lab classes, so for numerical programming courses, those have lab components, and right now, depending on the amount of students, that's full face-to-face social distancing, and masks. So not too terribly different there for those classes. So, and again, we'll see how things develop. I think California is trending very positively. So we'll see how the school reacts to new CDC mandates and things like that.
I might add that I've had the pleasure of having high schoolers come to Chabot and take electronic courses with us for the past 2 years now. And those high schoolers have been remarkably enthusiastic, able to keep pace with their adult counterparts. And in fact, not only keep pace, but do extremely well in comparison to some of their adult counterparts, maybe because they don't have the stresses of needing to think about work or commuting or things of that sort. So maybe that gives them a little more time to be able to do their tasks more successfully. But they have been able to have a very worthwhile experience, and it gives them college credits that gives them a head start into what high schoolers can enjoy in a college environment, that they can be here shoulder to shoulder, elbow to elbow with adults in a college level course, earn their college units, and get a head start in their college career in these areas of either machine tools, electronics, or welding. So we're really excited to have this opportunity for high schoolers to come in.
Yeah, thanks for bringing that up, Frank. So you do have concurrent enrollment students, or they're coming in the evenings or after school?
Yes.
How about in your classes, Adam, just in case?
Yes, yeah. So we have hosted two in my brief time here, but I have to say, like along with Frank, usually those are pretty motivated students, and they do tend to outstrip our regular student body. So it's really great having them there. It also kind of lights a fire under some butts, so that's great.
See, there's a question. Jane asked, how do students register for summer? If you're a high school student, unfortunately, summer, the concurrent enrollment forms already past due. So if you want to sign up for one of these classes or one of these areas, you would have to do it in fall or future semesters. For seniors that are graduating, that are going to be our incoming students, you could still sign up for classes as long as there's still room in these classes for summer and fall. So registration has just opened up. So, well, for some of the students, if you completed all your required steps, which I'll have in our description to this YouTube video when it's uploaded, if you have all those steps ready, then you would be able to register for these classes. So look out for the steps there if you want to jump into these classes as soon as possible.
And we have room.
Okay, there's
You're
room.
welcome to come and join us.
Right on, right on. I know a lot of the students who are getting these videos are in related classes. So if you're interested in continuing in these paths, please come to Chabot. And if you have questions, you could also email Adam or Frank, and we'll also have the other advanced manufacturing instructors on the description. Are there any last things you want to mention, either one of you, about your areas before we end this recording?
Just that we have a lot of fun.
It looks fun, both your classes. I like it.
I wanted to give a kind of a call to anyone who is a sculptor or looking in the arts field. That's actually I have a master's in sculpture. I just wanted to say that this field is fantastic for you, because I gotta be honest, the art world's rough, and it was really great to go to school I was just here for a year. I went to Chabot before I became a teacher here, went out in industry. It's really great to enter a program where you get to play with like $60,000 pieces of machinery, and then go out and join a workforce where they give you that $60,000 piece of machinery to work with and to, if you're in the right shop, use for your own purposes. So if you're like a burgeoning inventor or an artist who's trying to figure out like, okay, like how am I gonna, I don't want to be a barista. Like, what do I do? There's some really great industrial fields here where you can kind of feed, your appetite for creative technology use while also paying the rent. So I think that's something important to say for everyone out there who wants to do something creative but doesn't know how it pays the bills. It generally doesn't. So find a side hustle.
Thanks for bringing that up, Adam. All right, well, I think that's all for today. If again, for all the people watching, all the students watching, or instructors, teachers, if you're watching this video right now, we're gonna have everyone's contact information sent out to you, and it's also gonna be on the description to this YouTube upload. And yeah, I just wanna thank you again, Adam and Frank, for joining us today, and Jane for helping getting this together.
Thank you for hosting. And we look forward to seeing the young people when they come in.
Thank
Take
you.
care.
Thank you for
Adios.
everything. Bye-bye now.
Thank you. Bye-bye.
Bye. I'll stop recording now.